Hi guys, back to learning again. I've been learning about race conditions recently and they are fascinating. Race condition actually happens when two different threads try to access a shared resource, a shared database or a variable or anything like that at the same time, which is not protected by any kind of synchronization mechanism. Sound very complex, right? Yeah, I know. So let me just give you an example. You have earned a coupon code, let's just say. You have a coupon code which can be applied only once for a person at one time. That's it. It gets invalid after that. So if that's 20% of coupon code, only you can avail that 20% and that too only once. But if that particular endpoint which is applying that promo code is vulnerable to race conditions, we can add that same coupon code to multiple accounts. Let's just say two or three or four accounts. If you manage to type that coupon code into the field and click on apply coupon code at exactly the same milliseconds in all the accounts at the same time, in an ideal world. That's how race conditions actually works because you were able to trigger the application to apply that promo code into all accounts at once. I mean, this is not exactly correct, but this is actually how race conditions work. Let's dive deeper into the concept. This is the lab that I have been working upon, which is provided by Portswigger, and this is very demonstrative about that vulnerability. Let me just copy this into Mozilla Firefox, which is my default testing browser. So, the primary purpose of this lab is to somehow purchase this lightweight elite leather jacket, which is $1337. Cool, so cheap. Let me just log into my account. These credentials are given by them and I'm logging in with those credentials, here. So we have a store credit of $100, which means we have $100 of cash in our account. And the price of this leather jacket is 1337, which is more than 13 times the amount that we hold in our account right now. But they don't care. The lab can be completed only if you are able to leverage race conditions and purchase this expensive leather jacket. How to do that? I'm not quite sure, but let's just see how the application works, how the application flow is. Let me just add a product into the cart. Okay, this is added. I'm going to burp and I'm taking that request and I'm saving it in repeater. So this is add gift card. Right. Let's go to the cart. It should be reflected here. Yes, it is reflected here. And when you click on place order, the checkout functionality executes, which means, you know, it's a process, but the outcome is that you'll get the product. Simple. Yes, we have bought a gift card and let me just copy that particular request as well. This is checkout. Right. So this shopping cart is working as expected. You add a product to the cart and then you click on checkout, it will check out. Simple. Let me just add one and keep it. So how is the flow of the application actually working? Let's just visualize since we don't have access to the backend code or the application architecture or anything like that. Let's just imagine what might be going on in the backend. I've made a very tiny presentation for this since I'm very bad at graphics. Bear with me. So this is what we are doing. We add a product to the cart and this is the cart. We have a product in there. And when you click on place order, the checkout functionality gets initiated, as I've already told you. And one thing that I'd like to point out here is that checkout functionality is not a single process or a one-step process. It contains multiple steps inside it, and each step will take some amount of time to get executed. So by the time application reaches from the step one to the last step, it will spend some time going through all those steps. But as per my imagination, I guessed that this might be how the checkout functionality be looking. So in the first step, it will check if the price of the product that you're trying to check out is less than the store credit that you have in your account or not. For example, we have bought a $10 gift card and the store credit was $100, which means you are able to buy because $10 is less than $100 and you are allowed to buy it. So once this verification check is done, it will move to step two, where the actual checkout process happens, which means they'll select a gift card for you and then, add your address on top of it and deliver it, all that stuff. And then it will move to the step three, where the mathematics happens, which means you've bought a $10 product, right? So your store credit should decrease by the price of that product. So it will reduce that much amount. $100 minus $10. It will have $90 in your store credit. Let's see. Right. Working as expected. True. This is the actual flow of the application. But let's just say we are distant. I mean, we are sent on a mission to buy a very costly product by giving us very less money. So ridiculous. So, how to do that? If you focus on the flow, the checkout flow here, the actual verification check is happening in the step one. That's where it is checking whether you have enough money to buy that product or not. So, if you somehow bypass this step, this first step, you can buy any item that you want, any item of any price. You can just buy it regardless of whether you have enough money in your account or not. So, how to do that? How to bypass that first step? Let's add a very cheap product, which means we have $90 in our account, but let's add a $10 product to our cart. And when you click on checkout, once the step one is done, where it will check if you have enough money or not, once the step one is done, before step two gets started, if you somehow inject that costly product into the cart, you win. Because the price check is already done in the step one. It won't check again. And the proper checkout happens in the step two. So if in between those two steps, if you somehow inject the costly product in as well, let's just say $1,000 product, while the verification happens in step one, it is only having $10 there. The total price of the products in your cart is $10. But by the time it reaches step two, the total price of the products in your cart is 1,000 plus 10, $1,010. And it will just check out all those products because there is no price check happening again. This is what we are trying to achieve. So now let's just see how we'll do that practically. I have already added this gift card, but to add this leather jacket, we also need its product ID. Let me just add it. Yep, it is added. Let me just take that request and save it in repeater as well. Right. Add leather jacket. Cool. Let's go to cart. And since the total price is 1347, which is a lot more than what we have, let me just remove that. And now, time for the actual magic. Let me just create a group of both of these, and I will try to send both of those requests parallelly, which means one request won't wait for the end of another request to complete. I mean, another response, and then they won't happen sequentially. That's what I'm trying to say. So, if you, I mean, as per theory, in an ideal world, by the time checkout reaches step 2, the add leather jacket request should get triggered and inject this leather jacket product into the cart, and we should be able to check out both the products and the lab should be solved. Let me try. Yeah, everything looks cool here. Let me reload the page. And nope, we didn't succeed. Let's try again. Add this to cart. Go to cart. Send this to again.
2,000 years later.
Great, great. We are able to solve the lab. And why didn't it work the first 6 times? Why didn't it work? Because there are, as I have already told you, there are an n number of factors that decides whether a race condition works or not. And almost none of those factors are actually in your control. There are n number of factors that decide when a race condition actually works and when it doesn't. And almost all of those factors are beyond your control. For example, let's just say there is this network jitter, or the hardware of your computer is not able to handle parallel requests, or the hardware of the server is almost too filled up to its neck that it is not able to handle two requests at the same time. Maybe it's not able to create two parallel threads due to unavailability or due to its restrictions, or there are a lot more factors that we can actually enumerate. So, what I'm trying to say here is it's almost like all those factors should align for you to actually perform a successful race condition attack. So, if you're not able to perform it, it's natural, it's almost expected. So, if you're facing a failure in the first attempt, go for the second attempt. If you're facing a failure in the 10th, go for 11th. Just keep on trying until you are fed up or you actually get the result. And now we have solved the lab.